Now in this demo, we're going to be looking at how to optimize your clean in place, commonly known as a CIP, in the food and beverage industry by performing a root cause analysis and reducing a cycle time. Now in this particular demo, we're going to be looking at how to address two different challenges within the food and beverage industry. This particular process that we're going to be looking at pertains to the manufacturing of dairy products, and there's a CIP that it's typically done between batches, but we know for a fact that there are some CIPs that have been taking longer than expected. That's information that's been raised by operators and engineers. So we're going to see how with TrendMiner we can analyze such a situation and perhaps set up some monitors to prevent these. The other scenario that we're going to be looking at, or the other challenge, has to do with troubleshooting CIPs that have not met quality specifications. So CIPs that at the end of them, we didn't meet, let's say, cleaning specifications within the vessels. In this dashboard, we have different visualizations. One of them, which is showing me what a typical CIP should look like, with a total average duration of 1 hour and 25 minutes. From my dashboard, I can quickly launch this trend of view, which is showing me whether or not I'm in production, and when I'm not in production, I'm running a CIP. With a value-based search in TrendMiner, I can quickly search for when that CIP tag is greater than 0 and sort all of my search results, all of my events based on duration. Right away, I'll notice some of them are taking over 2 hours, which makes me want to overlay some of these ideal or typical CIPs taking 1 hour and 24 minutes and compare them with some of these longer ones. I'll notice that the last phase, that water rinse, is taking much more longer for these anomalous CIPs or longer CIPs, which also makes me perform another search to find only these long CIPs that are taking over 1 hour and 30 minutes. If I want to monitor for this behavior, for this type of event, I can perform another search, save it, and from my monitoring window, I can configure an email notification. And by just providing my email address here, I can get an email notification if any CIPs is taking longer than 1 hour and 30 minutes. In the second part of the demo, we're going to be looking at these 5 failed CIPs where we have not been able to clean these vessels for a successful production afterwards. From my dashboard view, I can quickly launch this context hub view, which in just a few clicks, I can visualize these 5 failed CIPs with some underlying tags important for me. For in this case, what is known as line number 1, where we're going to be looking at the caustic flow and the most importantly, the temperature inside of the vessel. Looking at the caustic flow, you can see it's fairly constant throughout the entire caustic wash, but indeed the temperature inside of the CIP vessel here, we can see a sudden drop in temperature. Again, not meeting that specifications where it has to be maintained above 90 degrees. Now, with this particular other feature of TrendMiner, the cross-correlation analysis, we could look at other tags, upstream correlations that could help explain this sudden drop in temperature during the CIP, the caustic rinse phase. One of the tags that does show up as being highly correlated shows a sudden increase in its value. This particular tag here, it's a flow for a spray dryer, which does use steam. So perhaps this is depleting the temperature or the energy required to maintain that temperature inside of the CIP vessel. Now with this in mind, we can generate a new tag in TrendMiner, an aggregation, which just computes or represents the delta or the increase in steam consumption for this particular spray dryer. Having this in mind, we can quickly in TrendMiner also launch or perform a value-based search that finds all the instances when the steam consumption rapidly increases over time. And just like with the first part of the demo, we could save this value-based search so that we can then configure a monitor and get a notification via email if there is in fact an increase in steam consumption for this spray dryer, so that we can then take any action that might be necessary, perhaps postpone the CIP or just wait some time until enough steam, enough energy is available for the successful run of a CIP. To summarize, during this demo, we were able to address two different challenges. The first one has to do with having extended CIPs due to the continuous operation of the last water wash of the CIP. Something that, when eliminated, allowed us to reduce consumption of ultra pure water for those CIPs by up to 60%. Additionally, we were able to determine the root cause for having failed CIPs due to an abrupt increase in steam consumption in another part of the plant. This particular issue, when fixed, led to a production increase of 1 to 2%. In all, by using TrendMiner as a troubleshooting software together with its dashboarding capabilities, we can increase situational awareness amongst engineers with the use of monitors, which allows us to comply with regulations while also meeting food safety specifications.